So that's why the weasel didn't have a tail.
That's the real weasel.
I just made that up on the fly too. So, all right, so slope. Slope's what we're talking about. Slope is rise over run. We represent that with the letter M. And so if we've got 2 points on a coordinate plane, x2, y2, x1, y1, then we would write that as the difference in the y coordinates, y2 minus y1, over the difference in the x coordinates. Amazing stuff, right? Yeah. All right, thanks for making me look good. All right, so let's do an example, and that is on page, well, the first one is cog railway. On example 1 on page 165, it says a cog railway goes up the side of Mount Washington, the tallest mountain in New England. Anybody ever been to Mount Washington? Yeah, me neither. At the steepest section, the train goes up about 4 feet for each 10 feet that it goes forward. What is the slope of the section? So it goes up, so that's our rise, right? So slope M is going to be equal to the rise, which is 4 feet, over the run, and the run is 10 feet that it goes forward, so 10 feet. And so 4 over 10, we can reduce that to 4/10 or 0.4. And notice when you calculate the slope, your units here are going to cancel out, right? So your slope won't actually have any unit. If I happen to give you something that had measurements in it, the slope calculation will not have any measurement, any unit. All right, yeah, that makes sense to everybody? That was simple enough. Now, example 2 says find the slope of a line, and they give us 2 points that it passes through. So as long as I've given you 2 points, you can always find the slope, right? So here's a question for you. We're given 2 points. Our points are 0, 6, and our second point is 5, 2. And so here's my question. Since the formula that I gave you is y2 minus y1, which of these is y2?
Whichever one you want to be y2.
You just have to keep them consistent. So it needs to stay y2 and x2. You can't mix up, like call one of them x1. You know?
Do you want to teach the class?
I think I'm good.
You're telling them everything. I mean, you're giving away all my secrets. All right. What were you going to say again? Very good. The same thing. So it doesn't matter, like Brittany said. It doesn't matter as long as you're consistent with it, right? So let's say we're going to make this. Which one do you want to make? Since you were explaining it so well, which one do you want to make y2?
Could be the last one.
This
2.
one? All right, so we're going to make this y2. So what she's saying there is if this is y2 and this is y1, then we have to also make this x2, right? And make the other one x1. So it doesn't matter which point you pick. You just have to, you can't take the x2 and move it over here if the y1 is there, right? You have to be consistent. So this is x2 and y2, this is x1 and y1. So now we can use our formula. And we say that it's 2 minus 6 over 5 minus 0, right? So we had a whole bunch of names on that one. Let's see if I can do them in alphabetical order. So we first had Camille, and then we had, wait a minute. Oh, I'm already out of order. That's okay. I can use this little thing here. I can say Brittany, and then we'll say Ian. All right. Very good. So this gives us 2 minus 6 is -4 over 5. So -4/5 is our answer for the slope on this one. Now just to prove that we could have switched this guy around, right? Let's say we're going to make this now be x2 and x1. I mean x2 and x2, and x1 and y1, right? So do the same thing again, 6 minus 2, and then this is now x2, so 0 minus 5. So we get 4 on top and a -5 on the bottom. So overall, both of these are going to be -4/5, right? It's just when we did the calculation, the negative sign was on the top on one, and it's on the bottom on the other. But overall, we still get the negative number. Okay? Does that make sense to everybody? Yes. Yes. Thank you for the thumbs up. I had a kid in the last class that was like sitting here like this. I'm like, are you thumbing for a ride? What's going on with that? I don't really know. So since Cal gave me the thumbs up, dude, really, could you have done that a little earlier? I give up. I give up. All right, so let's talk about postulate 17. Postulate 17. All right, and that says, talks about the slope of parallel lines. All right, and it basically says this. I'm going to summarize. If lines are parallel, are parallella, parallel, how do I spell that? I don't even know how to do that. Parallel, that just doesn't work. There we go. Parallella, there we go. I got it. All right. This is your symbol, all right? From now on, that's how you write your name, okay?
Every test.
Right. So if lines are parallel, I do like to abbreviate that. Let me do that just so that you guys will get in the habit of recognizing what the symbol means, right? If lines are parallel, their slopes are equal. So two parallel lines will have the same slope, all right? So, example number 3 gives us two lines. And the lines look like this. Here, we've got a line this way, and we've got a line this way. And we glance at it, and it's like, well, they look like they're parallel. But, of course, you can never assume. You got to prove that. And they give us some points here. So we go 4, 1, 2, 3, 4, and they give us a point here. Oh, I did that wrong. 1, 2, 3, 4, 5. They actually went 5, sorry. So we got this one here, and we got another point at 1, 1, right here. And then on this one, we've got a point at 1, 2, 3, 4. That's way over. It really doesn't matter because you just got to make sure that it's like that. There we go. Right, so they tell us that this is 2, this distance is 2. And they tell us that this distance is 4. And this distance they say is 1. And this distance is 2. All right, so they have a nice little drawing there that shows all of that for us. But if we're on a coordinate plane, we can always count that ourselves, right, if we have the points. So normally, when you see something like this, you're not going to have these measurements given for you. But that makes it super simple, right? So if we want to figure, if this is line, if we just label this as L1, and we label this as L2, then the slope of line 1 is going to be the rise over the run. So what's the rise of line 1?
4.
Gabe?
4.
What's the run of line 1, Gabe?
2.
All right. Gabe says it's 4/2. Does everybody agree with that? All right. So that gives us an overall slope of 2. What about line 2? Someone else? That's not on the board.
It is 2 over 1, which
2
would
over
also
1,
be 2.
which is also 2. So the slopes are the same. So the second part of our question here is, are these two lines parallel to one another? And they are, because of postulate 17. If the slopes are equal, then the lines are parallel. Okay?
So if we were to have a quiz, and so if we were to be making a proof and we were to use this postulate, would we write postulate 17, or would we write slope of parallel lines? Or both?
Yeah, I mean, I would take either,
Okay.
unless I'm out of Oreos, as Ian found out, and then I may be less gracious. And then you just come to me and go, hey, Mr. Walker, this is the same thing. So yeah, I would expect with something like this, if you write postulate 17, then that's enough, that's sufficient, right? You're making more work for me, because then I'm going to have to look up and see what postulate 17 is, but I would give you credit for that, right? Or you could just say parallel lines are slopes are equal, something like that, right? Parallel, definition of parallel line, well, yeah, maybe, definition of parallel lines, I'd even take something like that, right?
Okay.
But just something, yeah, that conveys what the essence of this postulate is in some simple way, okay? Probably, a lot of times though, these postulates that are sort of all by themselves, you're not going to use those in proofs, so you're not going to have to worry about that, right? But it's always a possibility, it could show up. Any questions though about calculating that? And let me ask you this question. How can I just look at a graph and tell you whether it's going to have a positive or negative slope? Did we go over that? I've got a lot of hands, a lot of people to choose from here. I'm going to go with Mary. Oh, she didn't have her hand up. Sorry, Mary. Do you know the answer? All right. How can I just look at it and tell?
If the line is going upwards, like to the right, that's a positive slope. If it's going
So upward, so the opposite upward would be downward
Right.
as you go to the right.
backwards to the right.
Yeah, exactly. So I would agree. Would you agree with that, David? And who else had their hand up that wasn't on the board yet? Nobody? Oh, Paul, did you have your hand up? Are you sure, Paul? Was it just like was it like this?
Right here.
It was like way out here? Really?
Like right
I
here.
totally missed it. Next time it'd be like, ooh, pick me. All right? I'm feeling generous today. We talked about, gingerbread Oreos, and I'm just, why not?
Mention of it.
Right. All right. So Mary's exactly right. Right. So if you have a line that goes like that, as you go from left to right, if you see that the line's falling, then this is a negative slope. If you see that it's rising as you go from left to right, that's a positive slope. Okay. So that's just a quick visual way. So if you happen to do a line like this and you calculate the slope and you get a negative number, you're like, I did something wrong. All right. All right. So let's do another example. And that is number, find the slope of each line, which lines are parallel. So here they give us a bunch of lines, and they say which of these lines are parallel. And so, what are the slopes of all of these lines going to be in example 4? Are they going to be positive or negative?
Negative.
They're all going to be negative, right? So it's because you go from left to right, they're falling. What you're really thinking about is you're thinking, what are the y values doing as I move from left to right? And as you move from left to right, the y value of each coordinate is getting smaller, right? So the lines are falling as you go from left to right. They're all going to have negative slopes. And so they label that first line K3. So if we calculate the slope of that first line, again, it doesn't matter which point you pick, just be consistent. We'll start with that highest number there, that highest point. So 5 is the y value on that highest point minus a y value of 0 over an x value of -6 and an x value of -4. So minus a -4. I always kind of recommend as you're writing stuff down to not change the sign in your head and say -6 plus 5. If you're super confident in your math skills and you never make a mistake, then go for it. But I too often make mistakes when I'm working through problems, and it's just good to take this extra step and look at it like that, and then say that's the same as 5 over -6 plus 4, and that's 5 over -2. So we get a negative slope just like we expected, -5/2. Does everybody have the book so they're able to look on with me? Does anyone not have the book? Let me say it that way. That's good. Okay. So M2. Someone that's not on the board, walk me through finding the slope for the second line, K2. Anybody brave enough to do that? It's not on the board. I'm sorry, that chicken got in here. I don't know how he got in here. No? Anyone wants to give it a shot? Is there somebody doing like a Paul hand somewhere?
Oh, I can do it.
You want to do it? Nobody else wants to go for it? All right, Cameron, what you got?
So.
Oh yeah, you're not on the board yet, are you?
Yeah.
You need to do it. That's right. All right. You probably should be. That's probably my bad. All right. So what would I do?
So, it'll be y2 minus y1, so I'll just do 6 minus 1.
Yep.
And then that'll be over -2 minus 0.
All right. Good. So that turns into 5.
Yep, 5, and then another over -2.
All right. So our overall value is -5/2.
Yes.
So are those two lines parallel?
Yes.
Yes.
Those are. They have the same slope. So the last one, does it look like it's parallel?
Not really.
You don't think it does? Yeah, it's kind of looking like it's getting closer at the bottom. But I would just say on a test, you look at some of these on a test and you'll go, yeah, it looks like it's parallel. That would be a mistake, right? To just assume. Go ahead and do the calculation and make sense. So let's do the last one. I'll make sure it makes sense. And so we're just going to take 6 minus 0 on the top, and we're going to take 0 minus 2 on the bottom. We do get a negative slope like we expected, but it's 6 over -2, which is a -3. So that one is not parallel. Only the first two are parallel lines. Parallel. Up.
10.
All right. Any questions about that? You guys good? All right. Let's see. Writing equations of parallel lines is the next section. So this is the slope-intercept form that we should already be familiar with. Anybody who's not on the board want to give me the slope-intercept form of a line?
Y equals mx plus b.
Y equals mx plus b. Very good. Y equals mx plus b. Where m represents what, Jackson?
M is the.
M is
It's the slope, right?
it's the slope. Yep, that's the variable we typically use for slope. And what is the b? Who tells me what the b is? Joey.
Y-intercept.
That's the y-intercept, exactly. In other words, that's where this particular line is going to intersect the y-axis, right? So let's look at writing the equation of a line in this form. And so we're given a point and we're given a slope. So we're given this point 2, 5, and we're told that the slope of this line equals 5, was it? Slope of the line equals 5. Okay? So how am I going to figure out what the equation for this line is? So if I plug in the slope, y equals 5x plus b, right? I just took my 5 here and put it into place for the m. But I got to find b, right? When you write the equation of a line in slope-intercept form, the y and the x just stay as variables, right? It's the m and the b that should have values. And so I got to figure out how to find the b for this particular equation of the line. So what am I going to do? How am I going to do that with the information that they've given me? Yes. I'll tell you what. You start. All right. You say a few words for me.
You plug in the.
Y coordinate.
You plug in the y coordinate. Wow, that was so just like this. Do you want to say something else?
You also you plug in everything really, but the x and y coordinates.
Yeah, you basically take all of these values here, but yeah, what we were missing
Oh, I thought you were just asking for the Y.
for the first part. Yeah. So you got that part right. That didn't work so well though. The whole splitting up. Maybe we won't try that in the future. But you basically take all this information and just plug it in, right? And so if we do that, we've already written our slope in there. We plug in our value for x, which is 2. And so the only variable we've got left is b. And if I've got one equation with one unknown, then I can solve for that one unknown variable, right? So 5 equals 10 plus b. I subtract the 10 from both sides, right? Minus, some people like to write it like this. It's like we're going to subtract out the 10, and we're going to subtract out a 10 over here. So they do it like that. And they say -5 equals b. However you'd like to do that, as long as you come up with -5 as your answer, I don't care. All right? I mean, I do care, I just don't care how you do it. All right? And so what do we do now? Now that we've discovered what b is, what is the final equation of a line? Someone else. It can be someone that's already on the board because the rest of the class is the quiet part of the class. Isn't that right? We got some quiet people in here. Yeah. At least you're honest. I'm one of the quiet ones. Brittany?
Y equals 5 times 2 minus 5.
Y equals, now remember, when we write down the equation of a line, the final equation of the line should have the y and the x in it. So give it to me again with leaving the x in place.
5x minus y.
5x minus what?
5x minus 5.
Minus 5. That's exactly right. So she took the b that we had here, and we already had the slope kind of plugged in here. So we basically took this equation that we had figured out except for the b, and we just plugged the b in, right? So this would be our final answer. Y equals 5x minus 5. Everybody understand how to do that? Okay. Now, what if I gave you a problem and instead of giving you the slope, I gave you another point? Could you find the equation of a line that way? Aiden, you say we could?
You
Okay.
just use your slope formula to find the slope first.
Right, so if I gave you 2 points, we would be missing the elm, but we can calculate the elm just like we did it right here, right? If we have 2 points. So we would do some math and we would calculate our elm, and then we've got a choice. We've got 2 points that we could plug into our line. We can plug in either one, it doesn't matter. So let's do an example of that real quick. We'll just leave all of this the same, right? And we'll give you another point. And we'll say, what if I'll do one that's not in the book, so you guys can't cheat like an answer in the book. So what if we did 0.25 and we did, what do I want to do? Something really hard and complicated. Let's say we're going to go from, this will be 0 and this will be -2. All right, we'll see how that works out. So let's calculate the slope for this guy. Again, it doesn't matter which one we use first. We'll just label this for simplicity's sake. The first one will be x1, y1, this will be x2, y2, right? So we're going to plug in y2, which is -2. We're going to subtract from it y1, and then here we're going to have 0 minus 2, right? 0 and 2 x's, the difference of the 2 x's. So this is going to give us a -7 on the top and a -2 on the bottom. So overall, 7/2 is our slope, right? Everybody agree with that? So now, we've got this much of the equation for our line. Y equals 7/2 x plus b. And what we did last time is we took the point that they gave us and we plugged it into our formula. So which point do I have to use to plug into our formula? Cameron?
Either of them.
I can use either point. So which point do I want to use to plug in?
First one.
I'd say the first one.
The first one? So, both kind of have benefits, I guess.
No, the second one.
I like the second one. Anytime there's a 0 in one of them, then it's that kind of makes it a little simpler, right?
Yeah.
So if I plug in the second one, and I say y is equal to -2, and then I say that equals 7/2 times 0 plus b, and this term just goes away, right? This whole thing disappears, and I've just got -2 equals b. So that one's super simple. So yeah, I would, if you've got one with a 0 in it, that's usually the one to go with. But either one would have worked. We would have gotten the same answer. Let's just prove that. Math still wouldn't have been that hard because the 2's would have canceled out in our fraction there. So we would have said 5 is our y, 7/2 times 2 is our x plus b. And so we've got 5 equals, these 2's are going to cancel out, so 7 plus b. If I subtract 7 from both sides, then I get -2 equals b. So I get the same answer either way, right? And so I just take that b, plug it back in this equation, and I say that my final equation for a line is y equals 7/2 x minus 2. Okay? All right, so you guys are slope-intercept form experts now. You can find the slope. If I give you, you can find the slope-intercept form of a line if I give you the slope and a point, or if I give you 2 points. Are there any other examples that they do in the book? Oh, there is. So they give us one other one. Yeah, let me make sure that we know how to do this. How are we doing on time? Good. All right, so, but I don't want to do the one in the book. So, again, I like it. I like it when you can't look at the answer and you think through it. Let's pick one. All right, so let's do something like this. It says, write an equation of the line and that passes through the point P, and the point P is -3, 6, all right? It passes through point P and is parallel to the line with the given equation. And the equation that they give us is y equals -x minus 5. All right, so we've got to find the equation of a line that passes through this point and is parallel to this line. All right? Suggestions? Quit, go home? Definitely. Easiest way out, right? That'll never come back to bite me. Just quit, go home. What's my first step? What is it whenever we found the equation of a line over here? What did we have to figure out first? Yes?
The slope.
We had to figure out the slope. So we're trying to find the equation of a line that goes through this point, but they didn't give us the slope. And they didn't give us another point to calculate the slope by. They just said it's parallel to this line. So Ian, what does the slope of the second line have to be?
Well, there's a negative in front of the x, so that'd be like -1.
That's right. So his point is that if we think about the format of the slope-intercept of a line, then the slope of this line has got to be elm equals -1. Is that what you were saying?
Yes.
Right? You said A, because sometimes, did you say A? Did you say A?
I don't know.
Well, because I've seen it written like that, I think. I think I've seen it written as AX plus B. Some of you may have seen it written
Oh,
that way.
I didn't say.
You didn't say A? Okay. What did I hear? What did you say?
I don't know.
Did you say
think
gingerbread
I said
Oreos?
M.
Did you say that? No. You said elm? Okay. I'm old. That's my excuse, my fallback on everything. I'm old. Sorry. So elm equals -1 for this line. So what's the slope of our other line have to be if it's parallel? It has to be -1 also, because parallel lines have the same slope, right? So this is elm 1 for our first line, but elm 2 for our second line has got to be the same thing because they're parallel. All right, so now for this second line that they want an equation for, we have a point that the line goes through and we have the slope of the line. So now we're just doing the same thing that we've done before. We know that our equation for a line is y equals mx plus b. We take everything that we do know and we plug it in that. So we know that the y value is going to be 6. We know that our slope is -1. We know that our x value is -3 plus b. 6 equals -1 times -3 is +3 plus b. We subtract 3 from both sides and we say that b is equal to 3. Okay? Did I lose anybody? No? I'm old, I go really slow, so you guys should be able to keep up, right? So y then equals elm, which we said was -1, and when you got a -1 in front of a variable, you don't write the 1, right? The 1's always understood. So we just say y equals -x plus b, which is 3. Is that what you said? Plus 3? Okay, plus 3. So that would be our final equation. I'm not going to count it wrong if you write a -1 in front of the x, but you don't have to. We usually just leave ones out when they're connected to a variable. All right, any questions about how we did that? That's excellent. We might actually get out a little bit early. So the last thing that we need to talk about is perpendicular lines. And perpendicular lines. I don't, trying to see, we got parallel lines and perpendicular. Have we got a Lara in here? No. Oh, if we had a Lara, we could do perpendicular. That would be perfect. Oh well. Do you guys know a Lara that we could invite to class? No, you don't. Okay. Oh. I tried. So my wife's name is Lori. Maybe we could do perpendicular. Maybe she could come to class. here Tuesday through Thursday, so she'd probably be like, I'm not going up there on Monday. That's my day off. So we've got another postulate. This is postulate number 18. We're jumping now into section 3.7. And postulate 18 says this. Postulate 18 says two non-vertical lines are, what does that symbol mean?
Perpendicular.
Perpendicular, right? If and only if, right, that is IFF. I was so pleased on the test to see some of you guys use IFF. Nice. Passing on knowledge. They are perpendicular lines, or two non-vertical lines are perpendicular if and only if the product of their slopes is -1. All right, and then there's just a note here, and they have to make this note because the slopes of one of these lines is going to be undefined, and the slope of the other one is 0. But they make the note that vertical and horizontal lines are perpendicular. So we just kind of know that by definition. All right, but for every other, we have a couple of non-vertical lines. Then if we multiply their slopes together, that's what we mean when we say product, all right? So when we talk about sum, we're talking about adding numbers together. When we talk about difference, we're talking about subtracting numbers. When we talk about quotient, we're talking about dividing. And when we talk about product, we're talking about multiplying, right? So we take their two slopes, we multiply them together. If we get -1, then we know those lines are parallel, okay? So for example, if I have a line which is 1/2, has a slope of 1/2, and I have another line which has a slope of 2. Are those lines perpendicular? I said parallel, I think, a minute ago. I didn't say perpendicular. Are those two lines perpendicular?
No.
They are not. What would need to be true in order for those lines to be perpendicular?
One of them
Equal
would have
negative
to
1.
be a negative.
One of them have to be negative. Yep. I can make either one, right? And that should sort of make sense to us because both of these lines have a positive slope, right? So they're all going to be going in this direction, some way or another. Right? And if all of my lines have a positive slope, it doesn't matter how I draw them, they're never going to be perpendicular. When they're perpendicular, you're going to have one with a negative and one with a positive slope. Right? So that makes sense. If their slope's going to be -1, one of the numbers is going to have to be negative, and one of the numbers is going to have to be positive. So if we did this, then we could say, yep, 1/2 times -2 does indeed equal -1. And so those two lines would be perpendicular. Okay? So let's do some examples of that. And they kind of give us the same type of thing that we had before, except here, let me see if I can draw this one. Here we have to look at it and base it off of the graph. And so they do a graph here of where our lines cross there, and our line crosses here. So we've got a line that's going through like that. And then I've got another line that's at 3,1. Goes through like that. And so they tell us that this point is 3,1. I wrote it at 3,0. Great. Way to go, James. All right. Bear with me. I'm old. So 3,1. There we go. The line's not straight either. Even though it's a little wavy, that's still supposed to be straight. So they tell us that the point is 3,1. Here, they tell us this point is 0,3. And they give us another point down here at the bottom, which is -4, -3. So mine is clearly not drawn to scale, because that is not -4, -3, but that is at -3, so I'm going to have to write it there. But they give us these 3 points, and they say, tell me whether or not these lines are perpendicular. They kind of look like it, right? If I glance at it, it looks like that it's crossing at a right angle here. But in order to check this out, I'm going to have to do what?
Find the slopes.
Find the slopes of each line, right? So let's start with this one over here that has, is this slope going to be positive or negative?
Positive.
It's going to be positive because it's increasing, right? So let's do rise over run. We'll label this L1. We'll label this one L2. So we'll find this. We're expecting a positive slope for line 1. We do 3 minus -3, and then 0 minus -4. And so for the first one, that's 3 plus 3, which is going to be 6, and that's 0 plus 4, which is going to be 4. So we get 3 halves for the first line. We get a positive slope. That's what we expected. Good. Line number 2. We take the difference of the y values. I'll start with this one here so that I'll get a positive number on top. I'm expecting this slope to be positive or negative?
Negative.
Negative. That's correct. I think I just saw you say something, Annalie. So, she's one of the quiet ones. Impressive. Nice job. All right. So L2, 3 minus 1, and 0 minus 3. 3 minus 1 is 2. -3 here. So our overall value is also negative. So we get a negative number for our slope like we expected, right? So now, are these 2 lines perpendicular? How do we figure that out?
If you multiply them and if the product is -1, then that means it.
That's right. So I say 3 halves. So L1 times L2 should give us what if they're perpendicular? What should it give us, Olivia, if they're perpendicular? I caught her daydreaming. She was looking over at the board. What would their slopes be when I take the product of it if they're perpendicular? What do you think?
I'm stupid. -1, baby.
There
You
you
took
go.
her a little bit.
All right.
She got there.
All right, you got there. She called herself stupid, so I felt obligated now. I made somebody feel stupid. I didn't mean to do that. So it's got to be -1. So we multiply it together. 3 halves times -2/3. And we multiply that together. 2 times 3, the negative in the front here. 2 times 3 is 6. 3 times 2 is 6. 2 times 3 is 6. So sure enough, we get -1, and so they are indeed perpendicular. Are perpendicular. Okay? Good? So all of the other problems are just kind of the same sort of thing, right? I guess I should do one of these, because this is a little different. We haven't done this yet. But I do want you guys to understand this. There's all kinds of ways that I could give you this problem on a test, right, or on a quiz, where you use all this wealth of knowledge that you have. I mean, you guys are literally, I can see your heads swelling. There's so much knowledge in there right now. All this knowledge that you have, we can put that into practice in all kinds of different ways, right? I can give you 2 points. I can give you a slope and a point. I can give you 2 equations of a line. I can ask you if they're parallel. I can ask you if they're perpendicular. I could ask you, is it raining or not raining? That's not a part of it. I made that up. Yeah, that was a fast one. But so I could also give you what we're about to do with this problem here, and that is I could give you 2 equations for a line, but they're not in slope-intercept form, right? So what if I gave you something like this? I said we have a line that's 4x plus 5 equals 2. Try not to look at your book. Try to resist. 5x plus 4y equals 3. So what if I gave you this, and I said, are these lines perpendicular? What's the slope of this first line? Or can I tell it just from looking at this? You say it's 5.
Slope is
Can I?
Oh, sorry. That's not
Okay, that's not right. Well, I thought it might be. I haven't done the math yet, so. I was about to be really impressed. How do I figure out what the slope is for this? I'm going to have to do what to this equation? What does slope-intercept form look like? What's the equation that we
Y
call
equals mx.
y equals mx plus b? What have I solved for whenever I write down that equation? I solved for which variable? When I give you a problem like I gave you on the last test, and I say solve for x, what are you trying to do? You're trying to get the x all by itself on one side, right? So which variable have I solved for when I write it this way?
Why?
Y, right? I got y all by itself on one side. So what I've got to do for each of these equations is I've got to solve for y. And if I solve for y, then it will be obvious what the slope is. You guys see that?
Yes.
All right, so let's do that, all right? Because we like to do fun stuff like that in here. All right, so I'm going to make us some room. And let's solve for y on this first one. So what are we going to do first? We're just going to send the 4x to the other side. Get out of here. We don't like you. And put him over there. All right. How's it feel being on the right side of the equation, Mr. 4x? Not some fun, is it? And now we're going to divide both sides by 5. And so we're just going to divide each term by 5 like that. And we'll say 5y, then these 5's cancel out. Y is equal to negative 4/5 x plus 2/5. So what is, if we call this line 1, right? This is line 1, and this is line 2. What is the slope for line 1? Now that I've rearranged my equation and I've solved for y. Yes?
Negative 4/5.
You're right.
Negative 4/5.
Negative 4/5, right? So it's whatever the coefficient is of this x variable. So it's just negative 4/5. That's the slope of line 1. Does everybody see that? Did I lose anybody when I did that? No? Okay. Let's do the same thing over here, right? This time, we're going to shove 5x to the other side. When we send it over there, we're going to make it negative. So negative 5x plus 3. Divide everything by 4. Right? So we've got y equals negative 5/4 x plus 3/4. So that's solving for y in this equation. So what's the slope in this equation? Negative 5/4. So before I do any multiplication, just glancing at those two slopes, are these lines perpendicular? They are not. Because I said earlier when we were looking at it, one slope's always going to have to be positive and the other slope's going to have to always be negative, right? Because remember, our answer has to be a negative number. So one's got to be negative and one's got to be positive. Both of these end up having negative slopes. So when you multiply them together, don't be fooled by that. You look at it and you're like, oh yeah, one's the reciprocal of the other. These have got to be perpendicular. But remember, it has to be the negative reciprocal of the other, right? When we multiply these together, we don't get negative 1. When we do negative 5/4 and another negative 4/5, when we multiply that together, we get a positive 1, not a negative 1. So these are not perpendicular. Okay? Any questions about that? You see how sneaky we math teachers are? Throw you something like that. It's like, what? It was so close, but not quite, right? So I think everything else is just kind of the same stuff, right? Just the problem's reworded a little bit differently, oriented a little differently. But it's basically the same stuff.